Good afternoon, everyone. Thank you very much for coming to this talk on Hadoop in private clouds, public clouds, virtualization, and VMs. My name is Sanjay Radia. I actually was part of the Hadoop team at Yahoo. My team actually built Hadoop when we were at Yahoo. I was the chief architect of Hadoop Core, and kind of reminds me we did the first Hadoop conference in 2008. It was a room 1/4 this size, 200 people maximum that we had at that conference, and the cost was $195. So we've come a hell of a long way. It is over 3,000 people at this conference. So I'm going to talk a little bit about. I start off with virtualization, kind of go back to basics, and then what is virtualization, and does Hadoop actually virtualize anything? And then kind of look at public cloud. There's a spectrum of offerings, and I'll go to private clouds about VMs and Hadoop, how they interplay, when to use them for test, dev, POC clusters, production clusters, what should you do over there, and kind of give you a guideline for VMs and then kind of summarize. So virtualization is actually a concept that is a general computer science concept that predates many decades before virtual machines. Okay, and the general idea is that you have a resource or a set of resources that you want to slice and dice so that across a multiple set of users, so that each user has an impression that he's actually got a dedicated resource. And so, for example, an operating system slices and dices the CPU and virtual machine. Sometimes you actually want to give an impression that actually you have a bigger resource than you really have. In the case of virtual memory, you are actually given the impression that you have a hell of a lot more memory than the physical machine does. And does this, of course, by the magic of virtual memory. Okay, so examples are, as I mentioned, CPU and virtual memory. The abstraction that is provided by the OS is processes and threads and its virtual memory. If you look at storage at the upper level, it provides the abstraction of the file system. At the lower level, in some systems, it provides what they call LUNs. And then, over the last 10, 15 years, virtual machines have become extremely popular, although these were offered in the 70s by IBM. And these have also become extremely popular. And there you are really virtualizing the entire machine, the CPU, the memory, and all the devices. And then the next one is, what about Hadoop? Does Hadoop virtualize anything? That's kind of what I'll kind of talk a little bit about that. So what Hadoop does, Hadoop, of course, does virtualize. What it does, it lets the OS virtualize the hardware resources, because Hadoop kind of runs on top of either your Linux operating system or Windows. Instead, what it does, it virtualizes the network and each of the nodes' OS resources across the cluster. And so in this talk, we'll kind of talk a little bit about that and when to take advantage of that virtualization versus the virtualization that is offered by virtual machines and vSphere and things like that. So this is a quick kind of recap of the Hadoop architecture. Typically, what you have is you've in Hadoop traditionally a number of master nodes like the name node or the YARN resource manager. Then you have anywhere from 10 to thousands of slave nodes, which I've drawn on below. And you often talk to the master nodes to either submit a job or to open a file, but the actual data transfer and the bulk of the work is done on the slave nodes. One of the things that Hadoop does do is actually it moves computation to where the data is. And this is probably was one of two or three big ideas that Google introduced that we clearly copied in Hadoop. Okay, and the picture on the right kind of shows you that on a particular node you have a task manager that is running tens of tasks, and also you have a data node that is managing the storage on each of the disks, and it kind of carves that into blocks. Periodically, the slave nodes send block reports and updates on what's happening there, and the tasks manager sending updates on the task. And this is kind of how Hadoop works. So it basically, this is the overall architecture. And so what Hadoop does, as I mentioned, that it does virtualize this resources, okay? In case of Yarn, the Yarn scheduler really focuses today on CPU and memory. But at the lowest level in the Yarn scheduler, the resource request is fairly general. In fact, you look at the internal API for the resource request, it actually talks about resource type and how much resources you want. And this is fairly general, and in fact was designed to be very general so that it could be extended to do I/O, network bandwidth down the road. Okay, so in fact that you will see happening over the next few years. Okay. The other one is that it actually supports a very diverse set of applications beyond what is traditionally big data, like MapReduce, SQL, ETL. And in a sense, so lets you share the cluster infrastructure across a diverse set of applications, very much like what, for example, your set of infrastructure for your virtual machines does. It supports a very diverse set. And so Hadoop is also moving towards that. For example, Arun today at the keynote mentioned about Slider, which lets you run services. Okay. The Yarn container, which is really the task that it launches, is called it's called a container. And today it's a Unix process. Very soon it'll be the Linux container or its equivalent in Windows. And this is primarily done to provide isolation and resource management. But down the road, actually, Hadoop could easily launch VMs if it wanted to. There is really nothing at the bottom level that stops it. All the abstractions are fairly general. It has a capacity scheduler that focuses on giving, that is really focused towards a multi-tenant environment. And so then there's a second scheduler called the Fair Share scheduler. And the main difference between the two, one was developed at Yahoo and the other one was developed at Facebook. And the capacity scheduler focuses on capacity guarantees to the tenants and then does fairness as its second level. The Fair Share schedule is slightly different. It was done originally to do fairness, and then they kind of added pools for giving kind of the guarantees. Okay, so just that's kind of the difference. And the capacity scheduler lets you go beyond your capacity, but subject to preemption. So very much similar to what vSphere does, that you can actually decide what your reservation is. It guarantees the reservation. If you're not using it, somebody else uses it. So in some sense, a Hadoop cluster is actually, a shared Hadoop cluster is actually better than a dedicated Hadoop cluster. So if you and a bunch of your business units get together and have a shared Hadoop cluster, each of you are generally better off than having just a subset of the cluster dedicated, because when you are not using, somebody else can. And when they're not using, you get a bigger set of the chunk. So for example, if your data arrives late and you need to get some SLA met, your chances are much better in a shared cluster. And the operations people can actually make such scheduling decisions on giving priorities at last minute to let certain things happen if, say, things really get delayed and things like that. So really, it works out extremely well. In the capacity scheduler, what the biggest thing that we had when we introduced the capacity scheduler at Yahoo was, we talked to one of the groups and he said, look, I'm giving 25%, I'm paying for 25% of this cluster, and I generate, the bulk of the revenue at Yahoo, and I've got this other group that's sharing the cluster. How dare do they use my resources? And so they didn't like it, but they realized when they finally saw the capacity scheduler, they realized that it was actually better. And then you kind of give them a way to manage their resources by giving queues, and you can say which queues have how much capacities, and you have sub-queues to say if you're not using it, you really want your sub-teams to get priority over the unused resource in which order compared to, let's say, the guys in a competing project or something like that, okay? And there are OS limits and Linux container limits to do resource isolation and limits. So really, Hadoop was designed for multi-tenancy, okay? Then when it comes to HDFS, it's at the bottom of the system, and it provides a shared file system. And the main thing it kind of does in a multi-tenant environment is that two things. One is, of course, it gives quotas, and like the rest of the Hadoop system, it also has security for you to be able to use in a multi-tenant, okay? Very soon, what we'll be adding is something called memory for intermediate data, and there we are actually going to, again, give you the impression that you have way more memory than you really do by actually virtualizing it across the disks. So, if you have a cluster with several 100 terabytes of memory that you dedicate, we will actually virtualize that and give it on the disk. So they'll give you a much better, and also we'll be doing tiering across SSDs and things like that. So in a sense, you will get the impression that you have more SSDs than you really do, because they'll try and move the hot data in there. Okay. So what's kind of the rest of my talks? I kind of given you a little bit of preamble, prepare you that there is virtualization in Hadoop. So I'm going to kind of talk first about public clouds. There's a spectrum of usage over there and models are offered, but most of the public cloud offerings are based on using VMs. Okay, and one of the challenges is how to persist your data when your clusters are spun and up and down. I'll talk about that. And then I'll talk rest about is for private and public clouds, and VMs are really appropriate for test and dev clusters. In production, you are actually generally better off using Hadoop's own virtualization if you want to do sharing and multi-tenancy. But there are actually use cases for VMs. I'll give you guidelines on how to actually, what are some of the best practices for doing that. So let's start with public clouds. So at one end, what you have is virtual machines. Example is, of course, Amazon's EC2. You decide on your version of Hadoop, you get it, you install it, and then you run it. So Amazon EC2 offers that, Microsoft Azure offers virtual machines, Rackspace Cloud offers virtual machines, and I'm pretty sure there are more that I have missed here. The main model is you spin up your cluster, you spin it down, you take care of the stuff, and the main thing that you have to deal with is that if you have data that you want to persist across that, you have to put it in S3 or Azure storage or whatever the equivalent is in Rackspace, okay? So that is one of the things. And on the extreme right, which is really the Amazon EMR, they're really giving you a Hadoop application, not giving you a Hadoop cluster. And there the model is that you just submit your job. In this case, it's a Elastic MapReduce job. And it automatically kind of will spin up the cluster that is needed to meet the requirements of the stuff. Again, there, your data will be in S3, and I'll kind of come to the challenges over there. Okay. Then in the middle, over the last few years, we actually have kind of a spectrum of either hosted, deployed, or managed, depending upon which particular vendor you're going to, of Hadoop clusters. Okay. Example is that you have clusters that are either deployed on VMs or private hosts. And they basically give you an easy deployment. You don't have to worry about which version of Hadoop. They actually have chosen a version of Hadoop. Interestingly, it turns out that almost all the vendors that are offering a managed Hadoop service have all happened to have chosen Hortonworks distro HDP. And so Microsoft HD Insight gives you, a very easy manage. You just specify how many nodes you want. You can shrink up and grow down very easily. And they give you some job management queues. Rackspace actually kind of offers two models. One is on VMs, and the other one is on the traditional model of hosts on racks. Okay, ATD also has a Hadoop service. And again, here, you could spin it up and down, except for the case when you're hosted, because there the cluster and the data persist, because you don't really spin it up and down on a regular basis. Okay. And the other one that is kind of interesting is Altiscale. And they actually have they give you kind of a managed Hadoop cluster. You don't install the cluster yourself. In fact, you're running, in a sense, like a virtual cluster, Hadoop cluster, that is actually physically hosted on a real Hadoop cluster. So for example, in their case, you actually use the shared HDFS data nodes with its security completely enabled, but each user is given his own virtual names. Each user is given his own HDFS namespace in a virtual machine that is independent. Okay, so that's what they do. And at the upper level, they currently use Linux containers, but they can also use VMs. And again, here you can submit the jobs. It's a much more managed Hadoop cluster, and you can do whatever else you like in the models on the left compared to the left. As I mentioned, in the Amazon one, they have actually picked a particular version of Hadoop, which isn't typically the latest. So they have kind of picked a version that's 2-3 years old, and they kind of over time, pick up some of the improvements in Hadoop. Okay. While all the ones on the left, either you pick your own or they have picked a version that's very recent, and therefore you get all the benefits of some of the recent ones. So this is kind of the picture on the public cloud. So what happens for a few of them, as I mentioned, like Rackspace and Altiscale, the cluster and its data persists. Okay. And what that means is that you don't have to worry about what's happening to your data afterwards, and so, for example, you have no problems running something like HBase on this or any other kind of Hadoop application. However, for all the other models, what happens is the cluster is spun up and down. So what happens is your data, your temporary data that you use while the cluster is running is no problem. But any data that you started with before the cluster existed and data that you want to end with after the cluster is spun down, you need to figure out what to do with this. And what they offer is something like a key value store. In a case of Amazon, it's called S3. And that is something that you typically load your data into, you use it, and then you do it. So what happens here is that data, if you access it while your system is running, while your MapReduce job is running or your Hive query is running, it will tend to be slower because it is not local. And if you recall, one of the kind of things about Hadoop is to actually move your computation to where your data is. And this data is actually not sitting on the Hadoop cluster, it's sitting on kind of side nodes, and you cannot move the computation there. So it will be slower, but if you're running a small little query once in a while, it actually doesn't matter. It works really well. And if you're trying to doing a proof of concept and test an application, there's really no problem. You're trying to see if a new API works or some change in data is working, is great. But if you're doing a lot of stuff, what people do is typically copy the data over, do a lot of work, copy the database. So for example, Netflix has a number of talks they've given at previous Hadoop summits. And they also have, on the slides you search down, they actually kind of do that model. They move the data in out. And so how can we do better? And so I'll give you one example of a couple of things that are coming down the road in the Hadoop community, and then one very interesting example of a particular vendor that has kind of done an interleaved Hadoop cluster. So if you're, let's say, running on a Hadoop cluster on the cloud, then I have a set of data nodes, then I will have a local HDFS. And that's great, as I mentioned, for temporary storage. But typically what you have is you have an S3 on the side. And typically you copy over. But what you actually will be able to do very soon in the future is to do a shadow mount of the S3. And what the system will do is lazily copy over the data. And this becomes actually fairly easy to do once, because we've introduced Hadoop Federation in Hadoop 2. And what that does is at the bottom level, it has something called block pools. So we can actually use a set of block pools for these cached data from S3 and kind of have a mount point that has a cache of the mounts of the namespace on S3. So something that is relatively easy to build because of federation. But this gives you the advantage that you don't need to kind of copy the data, or the data can kind of come in lazily. Okay, you could, of course, force it to be all moved over if you want, your initial set of applications to be fast. And this is the advantage that if you have a lot of data, you don't have to select, and the hot data will kind of move in. And so when the application accesses the data, it actually accesses it locally from the local side. If there is a miss, then the data will be copied over and accessed. Okay, so this is something that is relatively easy to build. And you should expect to see this, in the next year or so is what I would expect. The other kind of reverse is, so what happens when your data is completed? And there, the system, we can't quite use the same model. So what we are really looking at is that we are exploring right now is to have kind of the reverse, where you think of the block storage, S3 kind of as a block storage, and to be able to lazily write the fourth replica into it. So then when you shut down your cluster, it makes sure that the fourth replica has moved over to there, okay, and then the kind of shut down and copy the image over. So in this way, you can take your persistent data that you want and have it stored on there. So these are the two things that will actually make your cloud usage a little bit easier in the future, okay. An interesting use case actually for a vendor, I can't quite mention the name because I actually was going to ask them if I can mention the name before this talk, but I didn't get in touch with them. So they have a very interesting model. So they offer Hadoop as a service, but they actually, turns out, they have a lot of useful data that they want to offer to their customers. And so what they've decided to do, they thought about using something like an S3 style key value store, but of course you would suffer from locality issues. And so what they did was they kind of put a striped cluster on the top of the racks, and they use the normal cluster on the bottom. So on the bottom cluster, they kind of have a transient cluster that they spin up for each of their customers, but on the top, it's a persistent HDFS only cluster. So any of you guys who are from Yahoo or ex-Yahoo would have probably seen that this was one of the Hadoop configurations that we did play around with at Yahoo. So this is an interesting model that also can be done. And this may be actually a model that even you may find useful if you are kind of in a multi-tenant environment in your own organization. So this is something what we were using when I was at Yahoo for one of the experiments we were doing. Okay. So now I'm going to kind of switch gears a little bit and talk about Hadoop in private clouds, Hadoop's own virtualization, and the VM's virtualization isolation, what you should do. Okay, so traditionally, what is the motivation for VMs? They are much easier to install and manage compared to a physical machine. They give you elasticity, the ability to shrink and grow rapidly, almost instantly. And they only have one restriction, that they rely typically on very expensive shared storage. And that's kind of necessary because you need to be able to access your shared data from any of the VMs, any of the vMotion, or adding additional VMs to your load, et cetera. All of this is possible because of the shared VMs, okay? And it gives you ability to consolidate your infrastructure and actually improve your utilization. So this is really why a lot of the IT departments rapidly move towards virtualization, okay? And as I mentioned, that some of the benefits come from shared storage, but recall that this external SAN or NAS storage does not really make sense in the scale of Hadoop, because really talking about hundreds to thousands of machines, and SANs and NAS get very, very expensive at this. And also, they can actually not even take on the load of Hadoop. So if you have 1,000 machines, you can crush a very high-end NAS filer from NetApp just like that, okay? Because you can have jobs running on all of them and crush it. So typically, you end up using something like HDFS. But if you are using VMs, you have to deal with the VM's need for its VMDK storage and things like that. So that's something to consider. So what are some of the potential motivations for actually using Hadoop on VMs versus native machines on your production system, in your private cloud? So as I mentioned, public clouds mostly use VMs for isolation reasons. Okay, just kind of repeat that. But for private clouds, test dev clusters, and there you typically, one of the motivations may be that you want independent versions for each of your test environment and for your cluster management. So you may have a dev group that is using different versions of Hadoop, and you may want to be testing against different versions of Hadoop as you're moving over. So for that, you may want to have different versions. Okay, you may want to share infrastructure with known VM. And for production clusters, you may have questions about, is virtual machines better for elasticity? Is virtual machines better for multi-tenancy? Okay, so just explore that a little bit now. So elasticity in Hadoop via VMs. Do elastic data nodes work? Should I be shrinking and adding data nodes on the fly? This is the part that does not work at all. Okay, so for you to say, you know what, I'm going to cut down the number of data nodes because I don't need that much storage right now on the fly basis does not work, because Hadoop spreads the data out. And so if you start taking data nodes off, you need to copy the data. And that usually means a lot of copying around. So it is not, of course, it'll work, but it'll take you time to copy the data. And that's normally not what you want when you talk about elasticity. So not a good idea to move and to grow and shrink data nodes just on the fly in the afternoon and bring them back up at night or something. Hadoop is fantastic at saying, next week I've got 10 more data nodes I'm adding. You add them in, it works great. And after 3 weeks later, you decide that you're going to decommission 2 of them because new ones are coming, or you don't need that much yet. So on an occasional basis, Hadoop is fantastic. It deals with it automatically. But there is not what elastic capacity guarantee on the fly means, and that's what you should not be doing. Okay, compute nodes, it does work. It works well. But there's some challenges you need to think of. The first one that actually does is that Hadoop does actually make sure that your replicas that are placed, it makes sure that it doesn't put 2 replicas on the same data node VM, which are physically on the same physical host. Okay, and that's actually something that Junping, there was a code that he put in, and since then Hadoop can be used well for data locality in a virtual machine environment. Okay. However, there is one challenge you need to think about. If you are using a separate VM for compute, separate from the data node, then you will have to allocate a partition for the shuffle data. Today, that temp space for shuffle, which is what MapReduce uses, or for Hive, and the one that HDFS uses, it is all within the same file system. So it is not carved out, okay? Here you will have to carve it out because these are two separate machines, okay? So that's a bad thing, so you will have that fragmentation, okay? And this may actually be changed down the road when we move temp storage to HDFS, and that's one of the features that is possible because of federation, but we haven't had high priorities for that to fix, but that is something that can be fixed. The other one that has happened very recently is the short circuit read, which gives you optimization of reading from the local disk. Okay, so when you have a compute task running, whether it's MapReduce or Hive or anything, it'll actually access the local data, not even via a streaming socket, just via the file system. And that optimization is not there today if you are to separate the compute VM from the data node VM. Okay, and in fact, I don't even know how to do it down the road, okay? Because really, these are two separate machines in a sense. Okay, so you'll have to use something like shared memory, but that'll also have some override. And this optimization is a big deal for certain kinds of applications. It is a big deal for example, for HBase. It is a huge deal for HBase. In fact, this was motivated initially really for HBase. The other place where it's going to start making a big difference is that we now use memory mapped files for hot data, and we are now going to be using memory mapped files for intermediate data. Again, all of those things will become harder to do. Okay, so that's something to think about that you will potentially lose. And the other motivation might be, you know, VMs have great resource management, resource isolation. I have vSphere on the side. I can tell which tenant how much. Really over here, I want you to rethink that in terms of what Hadoop gives you. Yarn gives you a very flexible resource model, CPU, memory, others are coming, as I mentioned, and it manages across the nodes like vSphere does. Okay, but unlike the VM vSphere, the OS of Hadoop is Yarn, and so as it's scheduling tasks, it actually schedules it across. While in a virtual machine, as you're scheduling tasks, you only schedule within your VM. Okay, the capacity scheduler gives guarantees of isolation. And then one of the things that misses if you're running your applications on Hadoop that you're missing in the past was, you know, VM image management is so flexible, and Docker is going to fix that. Okay, so this is the kind of thing. So what are the guidelines? If you are using for test, dev, POC, virtual machines work great, and you may even share this with non-Hadoop. Having independent clusters is fine. Because independent clusters, for this kind of use cases, you don't have a lot of data, so it's okay to spin the clusters up and down. And the little fragmentation that you get that I mentioned may not be as much of a concern. And I'll kind of give you some more detailed guidelines on the next slide. Okay. But by the way, we know some customers who do use a native hosted on physical machines cluster for testing. So for example, I know Yahoo offers a test cluster that it tells all its development staff, this is where you run your tests. And so for example, whenever they go from one version to the next, they'll have a test cluster to say, here is a new version. I want all your apps certified before I move my production clusters to a new version. So there you can use virtual machine clusters or physical clusters, whatever makes sense for you. Okay. Production clusters, VMs is generally less attractive if you do understand your motivation and configure accordingly. Some guidelines on the next slide, okay? But remember, I'm repeating kind of that Hadoop has built-in elasticity for CPU storage, resource management, isolation, etc. Okay. So guidelines for virtual machines. This is the model one. You kind of have a base cluster. You put data node and compute node, which is the node manager in case of Yarn, on the same VM. Do not separate them out. And then if you want to kind of do some dynamic capacity, you can grow this cluster or shrink it a little bit, but don't think about growing and shrinking it like every 2-3 hours, because then that data will be copied back and forth. But if you need to add some compute capacity, by all means, you could go and add some compute nodes. Okay, and you could say, I need temporary compute capacity between 8 and 10 in the morning or something. You can obviously do that. Okay, and this particular base cluster, you should share it across tenants because Hadoop has good multi-tenancy things. And the only reason to not share it if you're using VMs is because you have 4 other reasons to need specific versions of clusters for different set of users, then of course a virtual machine is much more attractive than using a physical machine. Or if you need more isolation for some reasons. And the need for isolation will become less and less down the road as we use Linux containers. The second model that we've seen some people use is they have a base HDFS cluster and then a data node on the VMs, and then per tenant clusters on the top. Okay? Generally, the model one is better because it gives you the data node, the compute node data node shortcut, the read shortcut, which is important and is going to become increasingly important when you go to shared memory and memory mapped files. There is less storage fragmentation, as I mentioned, due to the shuffle data. And do share the cluster to the degree possible. And don't worry about that I need to put different tenants on different unless you really understand the requirements, because Hadoop is pretty damn good at that. You only really use model 2 if you need some additional tenant isolation but you want to share the data, okay? So this is kind of my getting close to the end. So let me kind of summarize. Virtualization is a general computer science term, and Hadoop virtualizes the cluster's hardware resources across the tenants. Of course, it uses the OSs so that it doesn't have to deal at the CPU level or the pure memory level, but at the next level, it does use the OS resources and virtualize it across all your jobs and applications and tasks and services in the cluster. Hadoop for the private cloud, for the public cloud, most of these systems are based on virtual machines due to the strong isolation requirements that you have in a public cloud, because you have competing banks that might be on that thing. Altiscale and Rackspace offer different models where your data persists. But for the other ones, the main challenge is your data persistence as clusters are spun up and down. And we describe some best practices on copying the data, et cetera, and then a couple of the new features that you'll be seeing down the road. Okay? For private clouds, for test dev POC clusters, both Hadoop on raw machines, Hadoop on VMs makes sense. We generally find that people tend to use Hadoop on VMs here because you often want to be on the fly, create, destroy. But for test, we do have seen customers do this to have actually test clusters on physical machines across many, many user bases. For production, Hadoop natively provides excellent elasticity, resource management, multi-tenancy. So therefore, take advantage of that. If your motivation for VMs is just the multi-tenancy, reconsider that. But if you must use VMs, and I'm not saying there are no good reasons to, then understand your motivations and take into account some of the configuration guidelines that I gave you, okay, in the last few slides. Thank you very much. Questions?
Anybody have any questions for Sanjay? Raise your hand. I'll come to you. Come.
Just a minor question. Hi, Sanjay. This is with regard to the production cluster. You do not specify the production cluster to have the VMs, as I understand, that because you already know beforehand what configuration and everything, you should use a native Hadoop rather than the VMs. Have I understood it correctly? And do you have a use case where in the production you need a VM?
No, generally in production you are better off not using VM because actually the system is more efficient. So all the VM generally have a tax on the data. There's a little bit of VM tax, more especially when you access data and network. And Hadoop is very data-centric, IO-centric, and network-centric. So generally your system will run faster. And Hadoop has really good multi-tenancy. So generally, I would say for production, go ahead and use raw hardware. So but if you happen to use VMs, follow the guidelines I mentioned.
Right. So more specifically, I would say then that is the case for the dev and the POCs environment as well, because I know pretty much and I can use a Hadoop native functionality. But only when I have to spin the clusters up and down multiple times is when I would require the VM. Have I?
Yeah, but in production, what happens is, here's the other issue in production. You normally do not bring clusters up and down in production because your data, where does it go?
Exactly, yeah.
Right? So generally for production, you don't have spin up and down.
Yeah.
Okay? So generally in production, have I seen a good use case for virtual machines?
can say
No, I
never,
actually
right?
haven't seen a really good use case for production.
Yeah, yeah.
But
Yeah.
you might consider having a production row cluster and then having some VMs that scale up and down
Okay.
if you
Yeah.
need some extra capacity on the fly.
Right. Yeah.
So that might work out.
Yeah. Thank you, Sanjay.
I work for RSA. We are an information security company. So in terms of use cases, let's say that we have a bunch of customers that are not necessarily big in terms of their big data, but we have a lot of them. So once you combine all of them in aggregate, then that warrants a big data platform like Hadoop. So from that perspective, one of the ideas is to use virtualization to sort of aggregate this large number of small customers into a bundle that warrants buying a Hadoop cluster. Otherwise, they'd be buying like a 1 node or 2.5 node Hadoop clusters that don't make any sense. So what do you think about this as an approach in general, and are there any pitfalls that you would see in that approach?
You're a vendor that actually is, in a sense, trying to provide Hadoop as a service, correct? Yeah. So you're a little bit like Amazon or Altiscale. So here is the thing, you are right. Now, if you were to offer, say, the model of VMs, then what will happen is each of your customer will still have 2-3 data nodes and 2-3 compute nodes. Each of them will be getting a tiny cluster. But their sharing of the data, the amortization of the data will not. So in your case, the model that Altiscale used might be better in the sense that you may want to offer a shared HDFS with individual namespaces for all of them. So you may want to use that. That model may work. But I'm pretty sure when your customers do not want to share the data across each other, right?
Well, yes, it's absolutely imperative that at no point, no matter what happens, none of our customers see each other's data. That would be very, very bad.
So even in the shared Hadoop, you can protect that, okay? But your virtual clusters or virtual jobs and things that you have on the top are going to be tiny clusters, virtual clusters. So really, in those cases, for the customer, using a hosted service like yours is absolutely the best way to go, because for them, the headache of setting up a 5-node Hadoop cluster is too much. As long as they trust to put the data in your site, and you can figure out a way to transfer the data in your site, they should work out. And there, you'll have to decide between when to use VMs and when to use the other model I mentioned. But it does make sense.
Thank you.
But if we have like different kind of workload, like big data workload or non-big data workload, like I have a data center which has database running and which has like some yarn workload running. So in that case, like how useful Hadoop would be for resource management?
Okay, so Hadoop, I think, will do very well in resource management. I think what happens in the kind of applications you're talking about, there's actually a different problem that sometimes even HBase runs into, is that most of the Hadoop jobs and applications, like when you submit a Hive query or something, the data is not, the service is not sticky. The service moves around, right? And the data that is created is actually spread across the cluster, because the creators of the data are tasks that are usually in multiple places. What happens in a sticky service, which is what will happen when you run a traditional service like what you see in HBase, is that the data will be recreated on the same place. So those nodes will become hot. HBase deals with it by making sure it recreates the regions in the same place. Okay? So if you're going to run, let's say, a web service or something like that, typically you're just reading data from a shared storage system, and usually that'll work well, and your servers are stateless, so something like that would work. But if you're running an application that is creating data, it cannot afford to say, it went down and then it came up 2 hours later, but now it is running somewhere else and it has no locality. So there with Yarn, there's something called labels that you can take advantage of. Okay, so I believe that over time, Yarn will become better and better at running services. We've just introduced something called Slider, with which we, in fact, started with HBase. So that's where we are kind of exploring getting this stuff. So I am actually, from a pure resource management point of view, I believe that Yarn will get as good as anything else you could do. Okay, it has got some of the same kind of underlying features that vSphere has. Okay, I know vSphere quite well. Okay, so from that resource management, I think it'll do a very good job. The underlying architecture is right. Will extend beyond memory and CPU. The stickiness of the data is a very unique thing. Okay, bad jobs do not stick. Services stick. And that's the area that we'll have to figure out how to actually get better. And on a case-by-case basis, there are ways to deal with it by use of labels. And we will do a better job of that over time. So I'm actually very optimistic about a Hadoop cluster infrastructure being used for things that are non-big data down the road. But what might even happen is a customer might say, I've got so much big data, I don't need to share. Okay? And also the nature of machines that you use for big data versus, say, non-big data, the sweet spot in what kind of machines to buy may be different. So that may influence whether you want to consolidate or not. But I do believe the architecture things in Yarn and the system are there to let you move towards the potential of sharing. And I'm pretty optimistic about that.
That is the end of our Q&A. So thank everybody for coming. I give Sanjay a